welcome back. We're going to continue our discussion today on the antiderivative that gives us natural log of x. That was the antiderivative of our uh, 1 over x here. If we take a look at example number 3 here, I'm going to use u substitution. If we take a look at example number 3 right here, we're going to use u substitution. We're going to let u be the bottom because the derivative of x squared is just x. I know it's going to cancel there. But I'm going to be the whole bottom. And remember, if I think of this as an entire quantity, the entire power is 1. So my u is just going to be this x squared plus 4, and our du is 2x dx, giving us dx is du over 2x. When we rewrite our integral, we're going to have this x over u. Look, your x is over u. Du over 2x, and the x's cancel. And what I'm left with on the inside, I'm bringing out that 1/2 times 1 over u du. It's over u because remember, u's on bottom. When we integrate this one, we're going to get this 1/2 natural log of u plus c1. And I'm just going to replace my u to give us natural log. Our u is this x squared plus 4 plus our constant of integration. And there's our answer right here. Number 4, this is our definite integral. We know it's a definite integral because we have bounds on it. So this is the one where we don't need to put the plus c. Like before, we are going to use u substitution. If I look at the bottom, I have this x cubed plus x. So I am going to let the bottom be my u. So my u here is going to be x cubed plus x. Our du therefore becomes 3x squared plus 1. Now, and I know I'm on the right track because take a look at what's on the numerator, 3x squared plus 1. That's the same as my derivative. I know I'm on the right track because they should cancel. Solving for dx, we get du over 3x squared plus 1. So, and we would answer this, we would plug this in. We would get 3x squared plus 1 over u du over 3x squared plus 1. The 3x squared plus 1s will cancel, and what we're left with is 1 over u du. Now I'm going to go ahead and change my bounds. Okay, I'm going to go and change my domain here. When x is, let's see here, 1, u is 2. When x is 3, u, well, 3 cubed is 27, plus 3, we get 30. So I'm cubing it, right? And I can get my domain 2 to 30. Because this is 1 over u, we're going to get our natural log of u. Remember, our power there is 1, so I get that. That's why I get that u. I don't need to put my plus c, but I'm going to integrate from 2 to 30. And we apply the FTC, f of 30 minus f of 2. And this is really easy. We get the natural log of 30 minus the natural log of 2. And there's our answer. Now, if you want to be really fancy, you can use your log properties. If I have the natural log of a minus the natural log of b, which is what I have here, I can write it as the natural log of a over b. So I could write this as the natural log of 30 over 2, which is just the natural log of 15, but that's fine right there. Our answer, there we have boxed in, is fine right there. So go and try number 5 if you want to go ahead and try that one. I'm going to work it. I'm going to let u be my bottom because my power down there is 1. If I look at the whole quantity there. And if I let u equal x squared plus 2x, our du is 2x plus 2 du. Now notice it's not the same as my x plus 1, but I can factor out a 2. Oh yeah. Du, and, oops, sorry. These should be dx's. So I can say dx is du over 2 times x plus 1. Rewriting it, x plus 1 over u times du over 2 times this x plus 1. X plus 1's cancel. Be careful, this is 1/2 1 over u du in my antiderivative. 1/2 the natural log of u plus c1. Don't forget your absolute value. So we get 1/2 the natural log of x squared plus 2x plus your constant of integration. Very easy to do. Number 6, the same way. If I let this be my u on the bottom. Now, one way I can kind of tell, look, if I take the derivative, I get an x squared here, and I get an x here. And look, I have x and x squared on top. So that's kind of a hint for my u there. So I'm going to let u equal here x cubed minus 3x squared. Du would be 3x squared minus 6x. 6x, we found it. Dx. I'm going to factor out my 3, and I get 3, and I get x squared minus 2 dx, giving us dx is du over 3 times x squared minus 2. Writing out your answer, here we get x squared minus 2x over u, du over 3 times x squared minus 2x. I forgot my x. That's what happened here. So I forgot my, oops, sorry, deleted it. So I forgot my x right there. There we go. There it is. Now it's correct. And those cancel out. Be careful. We're left with a 1/3, 1 over u, du, and that's going to give us 1/3 the natural log of u plus c1. And just replace u. The natural log, x cubed minus 3x squared, plus your constant of integration, and there's our final answer right here. Okay, we're going to pause here, go on to my next video, and we're going to take a look at what happens if we have a rational function. And these are really easy to do. I will see you then.